Welcome to my video tutorials and thank you for tuning in. We have got a quadratic function x squared plus 1. We have got 6 questions to answer. Let's start with the first question. Sketch the graph of f of x. The domain is the set of all real numbers. So my graph is a quadratic, is a U shape, and it has a y-intercept equal 1. And the turning point also is 1 for this one. Alright, so let's sketch the graph. So this will be my graph, and I need to mark the key points in this graph, or for this graph. It's just this one here. There are no other intersections with the x-axis. So I call this one f of x. So that's part A completed, or part 1, I should say. State the range of the function of x. Graphically, you can see the lowest value of the graph, the quadratic graph, is 1 or 0, 1. This will give us an indication of the range. And so we're going to say, number 2, I'm going to write it down here. We just say f of x is greater or equal to 1. Question number 3 says, explain why the function f of x has no inverse function. Now, for a function to have an inverse, the original function f has to be a one-to-one type of function. Now, this function here, or any quadratic, are many to one. So to answer question part 3, we're going to say, because the function f of x is not a one-to-one, I'm going to say f of x is not a one-to-one. Suggest a domain for which the function f of x would have an inverse. Now in part 3 we have discovered that the function does not have an inverse because it is a not one-to-one type of a function. So in part 4 we need to suggest a domain that will make the function a one-to-one rather a many-to-one. If I draw a horizontal line across my graph, you can see my graph is intersected at these 2 points here. At this point here will project onto the x-axis, will give me x1. This one give me another point, we call it x2 if we want. And therefore you can see this is what makes this function a many-to-one, because there are 2 values from the domain correspond to 1 value only from the range. So in order to make this function as a one-to-one, we need to ignore either this part of the graph, leaving us with this. Therefore the domain will be x greater or equal to 0, because this graph corresponds to the positive value of the x-axis. Or we could ignore this part of the graph and keep this part. That will give us a domain that is less or equal to 0, because this part of the graph, if we keep it, is on the negative part of the x-axis. So we have 2 different domains we can suggest. The first one is x less or equal to 0, or x greater or equal to 0. Now for part 5, to sketch the graph of the inverse function, we need to have a line of reflection, y equal x. This domain here represents the part of the graph, this one here. This value needs to be reflected onto the x-axis. And the reflection is going to be something like this. So this is my inverse function graph. For this domain, this is the part of the graph. We need to reflect this value here. And the graph will look something like this. Now for the range, we know that the range of the inverse function is same as the domain of the original function. So the range for this function is going to be less or equal to 0. And for this function, the range will be greater or equal to 0. And that completes the answer to this exercise. I hope this video tutorial was helpful. Thank you for watching and take care.